So John and I are going to be talking about PFAS this morning, and specifically some of the things that have been changing, because it's, if you're following it at all, you know there are been pretty much constant changes in really the last couple of years, and especially in 2024. It's been a time of very rapid change for PFAS. PFAS is a group of chemicals. That's one of the things I want to stress today. There are several thousand known chemicals in this class of fluorinated compounds, and some of the rules are targeted at broader groups of PFAS, and some of them are very specific. So as you kind of get into the weeds on some of these rules, that's one thing to note, is that the different rules cover different compounds. And so we kind of talk about PFAS in general, but the specifics of a lot of that are really important. There are some unique things about PFAS that make them really problematic. The big one is how ubiquitous they are. You see this figure over on the right that shows all the different places where you can find PFAS. So this is not just something that exists in some industrial process. These are in consumer products. These are in products that are touching our food, touching our face, and they're not just in there as like a contaminant or a byproduct. We put them there. We sprayed the pizza box with PFAS because it made the grease not soak through. So that's really one of the kind of inherent challenges right now with the way PFAS is being regulated and the way it's being used, is that it is used in a lot of different products, both industrial and on consumer products, and it continues to be used. So we have not said, oh, PFAS is a problem, we're going to stop using it in all these things. We've said PFAS is a problem, and here's a bunch of regulations about it, but we're still putting it in all this stuff. It's still in your eye makeup and on your pizza box. And so that's really the heart of the challenge of kind of implementing a lot of these regulations, and where a lot of the questions come from for us in the environmental world about, what is this going to mean as we start to test for it and look for it in more places. We know we're going to find it because we keep using it. And so how's that going to play out? So keep that in mind, just kind of in the back of your head as we go through the rest of these slides. Two major players that we will talk about today are PFOA and PFOS. A lot of acronyms, and they're all pretty similar. So remember, PFAS was a group of several thousand chemicals. PFOS is one specific chemical, this one right here. So keep that in mind. In terms of the regulatory landscape, this is where I said a lot has changed, and especially in 2024, kind of the year of PFAS. A lot of changes in the spring. There was a big push by EPA to get these rules out ahead of there's a marker like 6 months before the next administration, because the rules could be overturned if there's an administration change and there's a congressional review process. So there's a big push in the spring. You can see a lot of those rules came out in the spring. Things continue to change. This latest rule was last Thursday. So that's how fresh all of this is, how quickly all of this is changing. I'm going to got a slide about each of these changes. Won't spend a ton of time on it. So if you've got more questions afterwards, definitely come and find me and let me know. I'll be here all day and at the game. First up, TRI reporting. Some of you may have been following the PFAS requirements and TRI reporting. It's been there for a while. There are some changes coming up to your next reporting year. One of them is that there are more compounds that are reportable. So again, this is where you have to pay attention to those specific compounds. It's not all PFAS that are reportable, but there are quite a few, 196. That's a lot. It's more and more every year, and I think that trend will continue. They'll keep adding more of them to the list. There was also a recent change to designate PFAS as a chemical of special concern. And for TRI reporting, what that means is it did away with the de minimis. So in the past, a lot of you, even if you thought maybe you had some PFAS at your site, probably didn't have to report it for TRI because it was below the de minimis. Now they have gotten rid of that de minimis. And the other area where that's really significant is for the supplier notification, and this gets back to SDSs. And the de minimis for that is also going away, or has gone away. And I think that's an area that could be really significant for industry. Up to now, people that were trying to be really proactive about PFAS and wanting to know, hey, this stuff it's in the news a lot. Do I have it in my plant? First thing you did was you went and you looked at all your SDSs, and you might have reviewed hundreds of them, and you didn't find PFAS listed on a single one of them. And not surprisingly, because it's usually in very low concentrations, and so it didn't have to be listed on the SDS. This rule changes that, and I think there will be probably a pretty significant lag time before you start seeing that show up on new SDSs, but at least theoretically, it should start showing up on SDSs, even in places where it wasn't previously. So you're gonna make sure you have the most recent version of all those and that you're reviewing those, and just because you did kind of a top-down review in 2019 and you said, we're good, we don't use any of this stuff in our plant, you're going to have to keep checking that data, and probably not just another time, but continually check it, because it's going to keep showing up in more and more places on SDSs and other technical information. There's a change in February to list some PFAS compounds as RCRA hazardous constituents. Won't go a lot into this. The main thing I want to emphasize is this bottom point here, that what this rule did not do was list PFAS as a hazardous waste. I think a lot of people saw, oh, they're listing PFAS under RCRA, and now it's a hazardous waste. It's not. It's a hazardous constituent. It has to do with cleanup at hazardous waste sites. Hopefully doesn't impact any of you. That's what that change was. One of the more significant rules was the finalization of MCL's, maximum contaminant levels, for drinking water. On one hand, this is really significant. This is some of the first limits that really came out on PFAS, and there had been a lot of talk about them for the years leading up to it, and they were finalized this spring. And they're really low. You can see here we're in the part per trillion. So on one hand, this is a really significant rule. On the other hand, it still doesn't have a direct impact on most of the people in this room, maybe everybody. I know we have some utilities here. I don't know if anybody's on the water side, but most of you are not making drinking water, right? That's not your product. And so this rule doesn't directly impact you, but there may be a lot of indirect impacts on you from these new limits, which again are very low. We're in the part per trillion. That is hard to even wrap our minds around what it is. It's hard to even sample at that low. John's going to cover that later, but that's a real challenge. Just to help you visualize it, a part per trillion is a single drop of water in 20 swimming pools, not one swimming pool, but 20 of them. So 4 parts per trillion, 10 parts per trillion, that's 10 drops of water. Again, not in one of these pools, but in 20 of these pools. So really, really low concentrations. And we know that these PFAS are in our drinking water. That's why it was necessary to put this rule out there. And so that leaves a lot of questions for manufacturers. Even though these limits don't directly apply to you, because again, you're not making drinking water, what remains to be seen is how that's going to kind of flow through the rest of the chain. So what does that mean for your NPDES permits, for your pretreatment permits? To what extent are the utilities, the POTW, is going to have to kind of pass on some of these limits to industry so that then at the end of the pipe, they can still meet their limit? If some of those limits get passed on, what do we do about PFAS levels in the incoming water? We've recognized that this stuff is in our drinking water, so it's in the water coming into your plant. Are you going to have to somehow clean it up on behalf of the water system and discharge something that's even lower than what's coming in? Again, we're not there yet, but that's some of the kind of natural questions, I guess, that arise from the finalization of the drinking water MCLs. Several rules under TSCA have come out. This primarily is going to impact people who are either making PFAS compounds, you're manufacturing them in some sort of chemical process, or if you're importing those compounds. I don't think this is probably going to impact most of you, so I won't spend a lot of time on it. The TSCA rules are pretty far-reaching in a couple of respects. In one, because they cover so many known compounds. So the TRI was like 196. The RCRA is like 7 or 9 that are being listed. This is thousands of compounds, and they're not listed. They're kind of given by class. It also goes all the way back to 2011. So if this rule hits for you, you've got to go back, more than a decade at this point and report on these activities. The most recent rule I said came out last Thursday was EPA delaying this rule because their software is not ready. So if you are subject to this, you get a little more time. Everything got kicked back. First reports aren't due until January of 2026. There are other reporting obligations under TSCA. These are kind of like the normal reporting obligations, and PFAS is now subject to these normal TSCA reporting obligations. Again, may not affect most of the folks in this room, but another area where the regulations are changing. So you can kind of see how PFAS is starting to show up in all of these different areas. We've got EPA rules that address it. We've got TSCA rules that address it. We've got a RCRA rule that addresses it. And that's going to continue to expand throughout all of the different programs. And that takes us to the CERCLA listing, another rule that had been talked about for a while. There was a proposed rule. It was finalized in April. I think this is definitely the most significant of the regulatory changes that have come out this year, is listing these 2 compounds, PFOA and PFOS, as hazardous substances. And with that, I'm going to turn things over to John.
Thank you. Okay, so I'm John Young. I'm in the land group. So I'm going to talk a little bit about CERCLA and how that applies to the land group, which is what I'm a part of. Wes kind of already said this, but yeah, they did advance notice of public rulemaking as part of their rollout of all these regulations. And then they just finalized the determination of PFOA and PFOS as hazardous substances this year. So where we would probably see implications for that in land is with due diligence and with spill reporting. So now PFOA and PFOS are considered in scope for a phase 1 environmental site assessment. So if you're doing due diligence on a property for a real estate transaction or something, those have to be considered as the potential to be a recognized environmental condition. Other PFAS species may be under a business environmental risk or in the emerging contaminants section. And that could all change as this is all rapidly changing. A few places where you could see implications for that are with dry cleaners or with agricultural fields. Notably, agricultural fields were always really easy phase 1s for us because it's a clean site. But if that field has a record maybe of in the past receiving biosolids or wastewater treatment plant sludge as fertilizer or soil amendment, then that could be a red flag that could be a recognized environmental condition. Dry cleaners also noted as potentially having PFAS in their waste stream. There'd also be cleanup liability for owners potentially. And then for spill reporting, releases of PFOA and PFOS specifically, so just those 2 compounds right now, which could change, would be reported if the reportable quantity was exceeded, which is 1 pound, and immediate notification of the EPA and IDEM in that case would be required. And there was a recent article actually that noted, going back to the agricultural fields, that up to maybe 20% of agricultural fields have received these soil amendments from wastewater treatment plants in the past. So could be quite a large number of places. Several states are looking into this more carefully, like Maine and Michigan. Maine actually outlawed the application of biosolids in 2022. So there's been some issues. And also, I should say, EPA is conducting a risk assessment for biosolids right now, and that should be due, they say, this year. But there's always delays with everything with what they've been doing. So I'll talk a little bit about sampling and analysis. When people first started, sampling for PFAS, there was a lot of uncertainty about, being ultra conservative and extra cautious. And it kind of seems like all that precaution was not based on, actual scientific basis. So in reviewing, various guidances, we at KERAMIDA, I referenced this Strategic Environmental Research and Development Technical Report. And one thing that they did was a bunch of soak tests for sampling materials to basically see if there was leaching and that if PFAS was likely to cause, cross-contamination based on your sampling materials. So if we're out sampling, it's helpful to divide your sampling materials into two categories, Category 1 and Category 2, those which would have the ability to come in direct contact with the sample and those that wouldn't. So things like tubing and water level meters or soil sampling equipment would be Category 1, whereas, the PPE that you're wearing and the boots that you're wearing, because there's a lot of concern about, sunscreens and lotions and your Gore-Tex boots and Scotchgard clothes, because those all are known to contain, fluorinated chemicals. But basically, it kind of boils down to, having common sense about an exposure pathway from the sample to whatever you're exposing it to. One of the examples I heard was if you're not pouring the sample off of your Gore-Tex boot, it's probably okay. You still want to use precaution, but that's just something to consider. Obviously, Category 1 materials that contain PFAS like PTFE, which is the trade name for Teflon, like Teflon tubing, and anything in seals and gaskets should be avoided. And you just have to consult manufacturers' statements. But as Wes said, maybe that's not in manufacturer's statements, so you have to be cautious. So again, some of the recommendations that we've aggregated and synthesized from various sources are for your tubing and bottles to use high-density polyethylene, polypropylene, silicone, and acetate. So this is the kind of things that we're considering. Use powderless nitrile gloves and not latex gloves. Don't use low-density polyethylene bottles, but low-density polyethylene bags like Ziploc bags and trash bags are okay as long as they're not coming in direct contact with the sample. One example actually is that for your soil sampling containers, they used to have a Teflon cap, so we wouldn't use those any longer. And obviously, when you decon in the field, you should be deconning with PFAS-free water. Here's a list of unacceptable materials. Teflon tape and tubing, obviously, as I mentioned. Interestingly, glass bottles have been shown to adsorb PFAS directly to the bottle, so it could bias your samples. And you still want to use precaution, even wearing fabric softeners, clothes that are freshly laundered with fabric softener or with Teflon fabric protectors, you want to avoid. And avoid unapproved lotions and sunscreens. Brands like Off and Banana Boat have been, a lot of them, it's all in the guidance if you want to look it up, but they've all been certified, a lot of their brands have been certified as PFAS free. So I'll talk a little bit about the laboratory methods. These drinking water methods, 533 and 537, those are significant because those are the ones that have the sensitivity that you would use to be able to detect low enough quantities for the MCLs, so that 4 parts per trillion. I think the limit is something like 2, the limit of quantitation. And then 1621 is kind of interesting. That's not finalized yet because it's a broad screen. It doesn't test for specific compounds, but it tests for total organic fluorine or just an aggregate of carbon-fluorine bonds. So that is of note because there's been some discussion of regulating PFAS as a whole class instead of specific compounds. Like Wes is saying, there's thousands of these compounds. How are you going to go through and pick 1 or 2? They have replacement chemicals for PFOA and PFOS, but those might be what they call precursors, and they break down into other chemicals. So it's just it's a Pandora's box. So if they were ever going to regulate as a whole class, that would be significant. EPA 1633 is significant because that is the one that EPA would be recommending for use in NPDES permits. So some states already have requirements for PFAS sampling in permits, but it's not a federal requirement yet. But this is the one that they would end up using. 8327 is an older method, but that one doesn't have quite the sensitivity that you see in the other methods. So it's a more cost-effective method, but also it doesn't have quite the sensitivity. But we've used it, and it does have the required sensitivity to get below groundwater and soil screening levels that you would see in the IDEM R2. So, oh, look at this dude. So we've actually proven this in the field, and some of the guidance that I mentioned earlier is the Michigan EGLE and the ITRC, and those are a couple really good resources for sampling guidance. So we used those to kind of synthesize and adapt our own soil and groundwater sampling SOP. And so we did sample at a farm field, and we had positive PFAS detections, but we had no detections in our field blanks or equipment blanks. So we feel confident in our sampling methods there. The bottom line is that, like Wes talked about, these are present in a lot of consumer products, and they end up in waste streams, and they aggregate in wastewater treatment plants or landfills, and they end up in your water systems, and they even end up in really remote environments. So they are kind of everywhere. They are known to have negative effects on our health, and PFAS is an interesting intersection between scientific understanding, technology, and the regulations that are all kind of coming together based on EPA's roadmap and developing analytical techniques. So that's all for us. So thank you.
Any questions?
Okay, I got a question.